Welcome to Physical Science in the AF. We are in progress, and we're going to just take a look at superposition and interference. We're going to review some stuff we've seen already. Now, you guys have this, so don't dig this up. I just want you to pay attention. Right? So, what happens when two crests meet, guys? What happens when they meet right in the middle? They double in size. So, I'm going to just call this the green thing in there. 1 plus 1 makes 2. And then after the fact, they pass through each other. I'm going to put the, oh, crap, that was okay. I'll do it again. That's a pretty crappy drawing. Anyway. Okay, we know this, right? This is a review. Shouldn't be anything that we saw this the other week. And I get it then, just as red sprinkle. That's called constructive interference. Then, another review. When a crest and a trough, a positive and a negative, meet, they flatten each other out. If one was positive 2 and one was negative 3, though, they algebraically or integer-wise, come out to negative 1, but it would still reduce the size. So I'm going to say when they meet in the middle, instead of flatness there, I'm just emphasizing that they are meeting there, but they pull each other down. Right? What happens is after the fact, this one continues through. Right? But this is one thing at a time. Even though it takes 2 dimensions to draw this, we call these one-dimensional waves. Because when it's at rest, it's just one long string, or a spring, actually. And it's one-dimensional, left and right. And we disrupt that. We're talking 2-dimensional. That's water surface. And then you warp the water surface. Now, a couple things. I'm going to do this right now, standing with you. Demonstrate this with a spring. I think you guys have seen this. Back when I was a kid, I'm going to pause the video. It's going to be a demonstration. So what we were playing around with is a standing wave. And we're going to jot something down because you guys, I'm going to give you the sheet. Okay. So for the recording, here's a diagram of a standing wave. This one is 2 complete waves. John, please there. I want you to label this, the water. Label that. First of all, the dotted lines here are troughs. Solid lines, so that's a low function, right? And the crests are the solid. And there's many of them. I've only labeled one. You already know them, right? So let's just see what I've done here with my diagram. I'm not good with colors, you guys won't take your mind. So label crest and trough, and then we'll talk about what these nodal lines are. They're already labeled. I guess, write down the word nodal lines. Do that too. You have to. Let's just think through what this is. The next 3 minutes. So remember, on a side view on a spring, this would be a trough, right? So on a wave, if this is the side view of a wave, right? This is a low point. Now, wherever I have a green dot, now I'm coloring over it because of this place. There, and so on. That's a low of one wave meeting the low of another wave. So what's going to happen? Will be what? Will it cancel? Super low or super high? You have 2 troughs. Deeper than any one wave would be. Yeah, it would be a super low spot. So it's constructive interference, even though that it's going lower. And 2 crests meet. So that is wherever I have a blue dot. That's where 2 crests are meeting. And that's going to be a super high spot. 1 plus 1 makes positive 2, right? Now, what the nodal lines are is wherever, Is this what color? Dark blue or what is it? Purple? Okay. Purple or dark blue? And I'm colorblind, so I don't just, you guys are confused, I'm deaf. But you notice anywhere I have these spots, that's where a crest meets a trough. When you see this, it doesn't show up crazy good in the video, but it shows up somewhere. That's where you have a node. Nodal line, so then because you got a bunch in a row. Now I'm going to put back to the video, and we'll see what this means.
Undergo constructive interference.
So that's what we're
The points at which these occur are highlighted with small red circles. If we follow these points, we can see that they fall along a line where constructive interference is taking place.
I only put down the destructive. It's too messy.
Here we can see a still image taken from the front of the ripple tank, which makes these points of interference clearer. Where wavefronts overlap, small red circles have been placed once more. By extrapolating between them, we can begin to see a pattern. However, to see the interference pattern clearly, let us turn to the excellent false stance